Hello, it's Keith here, and this is lesson 7 of the so-called ChibiFighter series, in which we look at this little game here. It's a sort of a fake Street Fighter parody, but it's really just a tech demo. And what we're going to do today is we're going to look at the AnimateSprite routine. Now, we looked at the animation scripting before, which does things like the walking, but things like the jumping and the gravity, and if I get knocked off the screen, I get pushed back in and things. These are done by the AnimateSprite routine, and we're going to look at that today, and we're also going to look at a few other small routines that don't really fit anywhere else. So that's what we'll be looking at. Let's go over to the code and let's check it out. Okay, so the first thing we're going to be looking at here is its animator's routine here. So the AnimateSprite routine, well, what does it do? Well, the first thing it does is it checks the life of the sprite. Now, the life, basically, if this is 0, for things like the fireballs, that's the secondary sprites, if you will, if they're 0, they shouldn't be drawn. So it's checking that, and if it's 0, then this sprite shouldn't be shown to the screen. In that case, it will simply return. However, if it's not 0, we need to do a few things. We probably want to run the object animator. This is used for any animator other than 0. 0 is a static sprite. You see, the animator of 0. Anything else is an animation state. So we are checking that, and in that case we need to set up the animator pointers. Now, each of the animated sprites has a list of scripts, and that varies depending on the player, for example. So we are updating those pointers in the animator pointers based on the current animator list of the current player. IX will point to the current player you see when AnimateSprite is executed, or at least the current sprite, sorry. The fireball will share the animator list, but that's a different sprite, and so IX would point to a different position in that case. So we're loading in the animator pointers, and then we're running the object animator, which handles the animated scripting for things like the legs walking and so on. What it doesn't do, though, is it doesn't handle the actual updating of the sprite for jumping and things like that, and that's what we're going to do now. So basically, our sprite's graphic may change, and because of that, the width and the height may change. So the first thing we're doing here is we're backing up the old width, and we're going to back up the old height as well later on. And this is so that when we remove the current sprite from the screen, drawing the background in its position, we can do that and we know what size we need to replace. So what we're doing here is we're updating the old width and height. And what we're going to do then is we're taking the width and dividing it by 2. And that's because the XY position of our sprite is actually the center of the sprite. And so we're dividing the width by 2 to calculate the top left corner for the drawing. We draw in a zigzag from top left to top right and then going downwards. And so what we're doing here is we're calculating the top left, and we're doing that by adding the top byte of the 16-bit XPOS to half the width negated, and so that's basically moving us to the top corner. So that's what we're doing there. We're checking if the XPOS has changed since last time, and if it has, we're flagging the sprite for update here. That is telling Mintar, which is the graphics routine I'm using, that this sprite needs to be redrawn. We're then basically updating the Z position here. We're loading in the Z position, and we're subtracting 8. Now, the Z position is basically the ground. We've got the X position across the screen, the Y position, which is for jumping, and the Z position, which is for walking up and down the ground. We've got a kind of 3-dimensional depth there. And the way we're simply doing that is it's basically an offset from the current Y position. And so we're calculating that, and we're storing it in D. We're then taking the height and backing that up, and then we're dividing the height by 2 and negating it, and we're adding the Y position. This is the jumping Y position up and down the screen, but we're then adding the D value that we just calculated from the Z position, and we're storing that as the new Y position. We're then comparing that to the old Y position, and again, if that has changed, we're once again flagging the sprite for refresh. So we're refreshing the sprite if the Y position or the X position has changed, and this is the visible Y position, which is also taking into account the virtual Z position. So that's what we're doing there. What we're going to do next is we're going to update the sprite information based on the actual sprite number. So we're loading in the sprite number for the current player sprite. This, for example, a frame of walking, or a jumping sprite, or a punching sprite, or something. It's depending on what the player is supposed to be doing. So we're loading in that, and we're effectively multiplying it by 4 here. And that's because the data for the sprite contains the address of the tile map and the width and height of the sprite. You see, here is a sample sprite information table. We have a pointer to a sprite tile map and a width and a height in pixels here. So here is a tile map. This is basically the pattern numbers that we need to make up a character. That I think this is Chibico here. So that is the tiles that we need to use, and Mintile will do that all for us. So we're loading in the pointer to that, and then the X and Y width, the width and height, sorry. So we're loading those in, and you can see that is what we have got here. So we're loading into D here the offset to that sprite info table. We're then adding the offset to the current sprite. We've multiplied the sprite number by 4 here to get the correct offset. We're then loading in the tile map for the current sprite, and we're storing those in sprite tile HL. We're then loading in the width and the height here. Now we are shifting those, dividing them by 2, because we work in logical units, but they're stored in the table in pixels. So logical units is 1 logical unit for 2 pixels, so we're dividing them by 2, and we're storing the new width and height in logical units here. Okay, so that's what we've done there. The next thing we're going to do is we're going to deal with the jumping. Now, jumping is a bit of a unique case. Basically, we have this sprite Y move, and if that's above 0, we're actually going to be jumping up in the air. This is how we deal with the jumping. And so for any time when that is not 0, we are basically decreasing the Y position by 1 and decreasing the counter for the remaining amount of moves. And so when we jump, we would set the jump to maybe 5, and then we would go up for 5 ticks, and then gravity will kick in and we go back down. So this is us moving up the screen, jumping. And once we finish jumping, what will happen is we are checking the Y position, and we're checking and seeing if it's less than 152. 152 is the ground position. And if it is, and we're not jumping, then we need to increase the Y position to basically return us to the ground. So that's how the jumping works in this game. Now, beyond that, we are then basically checking the X position, and we're doing the same and seeing if we need to move horizontally. Now, this can be positive or negative. If it's positive but not 0, then we need to basically increase the X position and move the amount of move back closer to 0. If it's negative, we need to decrease the X position and increase the move X move until it reaches 0. So that is basically allowing us to move left and right. Now this is used for forced moves, but like maybe if the player has been punched and knocked back, that's how that is done. That happens for a period. And so that's our remaining moves. The final things we need to do here are to actually remove the sprite from the screen. Now, Mintile is my software tile map routine, and it has a rather odd way of doing this. Basically, there are 2 procedures. The first one is we remove the sprite from the screen, but then to reduce the amount of flicker, we actually try and work out which tiles are going to be redrawn anyway by the next sprite, overlapping it. And so we 0 those, and making a sprite a tile 0 means that it's not actually drawn in the cache. Now, the reason we have to do this is because Mintile doesn't use a double buffer. It's designed for a single buffer, and that is to reduce the memory load on the destination system, because some systems can't double buffer or memory is restricted. Now, there is a bit of a problem with this because the half tile moves, sometimes it gets it wrong, and so you occasionally see bits of tiles left over, unfortunately. I could only think of 2 ways of resolving this, either the double buffer, which memory didn't allow me to do, or to have a more complex routine that calculated the offsets and the tiles that would actually need to be drawn on the next sprite in a more advanced way, looking at the sprite as a whole and calculating for each line the start and end more accurately. It would have meant a lot more code, and I wanted this to be a very simple, quick routine that I could port to more systems, so I didn't do that. And the net result is that it's not entirely accurate, but as I say, by 0ing, it means that we don't need to redraw every frame. And then what we're doing here is we're marking that the tiles have now been refreshed, because we've refreshed the background as required here. Now, I will just quickly show you what I mean by that 0ing routine. So if we just start up the game again. Now, if we start the game, what you should look at is the edge of the sprite. You will notice that the tiles around the edge of the player will kind of flicker on and off, but the center will not. So if you look, for example, you see Chibico's walking there. If I just zoom in. Oh, I'm getting attacked here. If you notice, the edge of the wings there are disappearing and reappearing, but the middle is not. Now, the edges are disappearing because of that remove sprite routine, but the middle is not, because the 0 sprite and cache routine is detecting that middle is going to be redrawn anyway and is marking them not to be updated by 0ing them in the cache. But as I say, it doesn't always get it right, and that's why occasionally you do see graphical glitches on the screen, which, as I say, is because this is a very crude tarmac routine, that it is small and easy to port, but is not perfect. Anyway, that's all we're looking at in that file. The final thing we're going to discuss is a few of the maths routines. We've got a range test routine. It's the exact same one that I've used in the past. Basically, we have a range and we have an X and Y position. We check if the two X and Y positions are within the range of each other. And we do that by subtracting the range and testing, and then adding the range and testing. And if the second object is within those two boundaries, it's considered in range. And we set the carry flag if the two have collided, or clear the carry flag with an OR if they have not. Now, in the case of range test IX, IY, we're testing if object IX is in the range of IY. And so what we're doing here is we are loading the X pos and Y pos of the two objects from the IY pointer and IX pointer, and then we are loading in the range, and it's a fixed range of OC10, which is a range of 12 units by 16 units. Now this is basically being used to test if object IX has successfully attacked object IY. And then so what we're doing here is we are actually basically loading in the flags from the IX object and seeing if the object is facing to the right or to the left. Basically, if it's facing to the left, we are subtracting 8 from the x-axis, and if it's moving to the right, we're adding 8. And that's because if the player is punching, if the player is this direction, the hit zone needs to be here, whereas if the player is here, then the hit zone needs to be about here. So the position is being moved accordingly depending on the direction the player is facing. That's what's going on there. The final thing we have is the do random routine. I'm actually using a much cruder random number generator this time, just for simplicity. It's just basically a simple set of rotations and XOR, and we're XORing into random bytes here from the random seed. This is a random number generator I'm testing for another simple project, and it's adequate for this game. It's not as good as the other one, but as I say, for this case, it was enough. So there we go. That's all we're covering today. We're going to go into some more of the code next time. If you like what you've seen, please like and subscribe as always. And if you want to support me, you can buy my books. I have 2 of them, and I'm basically covering pretty much every assembly language in one or the other. So please take a look at them on Amazon if you are interested in assembly and you like books. Anyway, I hope you've enjoyed what you've seen today. As I would say, all the source code's on my website. Download it and do whatever you want with it. Thanks for watching today, and goodbye.